Students, Sairam, this is Megha Miss here, and today we are going to continue with our lesson number 8, Metallurgy. This is our session 5 students. Okay, so in the last presentation, if you remember, we have studied about the basic principles of metallurgy, yes, and in that we have studied the concentration of the ore. Okay, different methods are there with which you can separate the gangue particles from our desired whatever the metal we want. Okay, so we'll proceed with that. Basic principles of metallurgy. Pure metal is obtained from the ore by the following stages. Means different stages we have to follow. During the extraction of metal from their ores, metal is obtained from the cation of metal. In this process, a metal cation is to be reduced. So we have to reduce a metal cation. How to bring about the reduction depends upon the reactivity of the metal. Means how much reactive that metal is. Upon that this reduction will depend. We have already learnt about the reactivity series of metals. Yes, in 9th standard also you have studied. Okay, so we'll proceed now. Now the second part which we are going to study, that is the extraction of metals. Extraction of reactive metals. First we will see how we can extract the reactive metals. Now the metals at the top of the reactivity series are highly reactive. Okay, their reactivity decreases down the series. As you come down from up to down, reactivity will go on decreasing. For example, potassium, sodium, aluminium are reactive metals. Reactive metals have large capacity to form cations by losing the electrons in the outermost shell. Means remember students, they will form the cation by losing the electrons which are present in the outermost shell. Okay. For example, reactive metals react vigorously with dilute acids to give hydrogen gas. And which type of gas it will give? So, hydrogen gas they will give students. Okay. So, they are going to react. The metals, they will react vigorously with the dilute acids and give the hydrogen gas. Highly reactive metals burn by reacting with oxygen from air at the room temperature. Their extraction has to be done by electrolytic reduction. What is that? We will be studying. Okay. Now, for example, the metals sodium, calcium and magnesium are obtained by electrolysis of their molten chloride salts. In this process, metal is deposited on the cathode while the chlorine gas is liberated at the anode. Now, you have studied electrolysis of water in 9th standard. Same process we are using here. Okay. The electrode reactions during the electrolysis of the molten sodium chloride to get metallic sodium are shown below. So, cathode reaction you will remember, Na plus electron will give you Na, that is reduction. 2Cl minus will give Cl2 plus 2 electrons, that is oxidation. So, see here both reduction oxidation will be taking place. Okay students, you will learn it properly what is the cathode reaction and the anode reaction. Electrolysis means you are going to pass the electricity, okay, through the molten chloride salts. It can be sodium chloride, it can be calcium chloride, or it can be magnesium chloride. Okay students, so we'll proceed. Now, extraction of aluminium. Now, aluminium being reactive metal does not occur in nature in the free state. You will not get it in the free state. Okay. Aluminium is the third highly abundant element in the earth crust after oxygen and silicon. Aluminium is extracted from its ore bauxite. Remember students, important. Remember the formula, molecular formula Al2O3.NH2O. NH2O means N number of water molecules. You know water of crystallization, you have studied in 9th standard. Okay. Bauxite contains 30% to 70% of Al2O3 and remaining part is the gangue. Means unwanted part. It is made up of sand, silica, iron oxide, etc. There are 2 steps in the extraction of aluminium. So, we are going to see that 2 steps. Okay. Now, aluminium symbol you will remember Al, A capital, L small letter compulsory. Atomic number 13 you will remember. Color silver white. Electronic configuration important to remember, that is 283. And if you remember the electronic configuration, you know the valency is going to be 3. As the last orbit, it has got the 3 electrons. It is easy for it to lose that 3 electrons and get the stability, right? Octet will be complete. So its valency is going to be 3. Can you see it here? Okay. I hope extraction, this basic information about aluminium you have understood. Okay, where you get it and what it contains. Okay. Now, concentration of bauxite ore. Bauxite is the main ore of aluminium. Remember students, silica SiO2, ferric oxide Fe2O3 and titanium oxide TiO2 are the impurities present in bauxite. These are all impurities which you need to remove. Okay. Separation of these impurities is done by leaching process using either you have two methods, Bayer's method or Hall's method. In both these methods, finally the concentrated alumina is obtained by calcination. So calcination is one of the process which you have to do for getting the concentrated alumina. Okay, now we'll proceed. First we will see the Bayer's process. Now in the Bayer's process, the ore is first ground in a ball mill. Okay, in the mill it is crushed. Then it is leached. Okay, leach means what? It is heated with the concentrated solution of caustic soda. Caustic soda is nothing but sodium hydroxide. Okay, but concentrated we are taking solution of caustic soda, NaOH, at 140 to 150 degrees Celsius under a very high pressure for 2 to 8 hours. Okay, in a digester. Digester is nothing but a tank like where it is continuously heated. Okay. Aluminium oxide being amphoteric in nature means it can as both acid and base it can form. So it reacts with the aqueous solution of sodium hydroxide to form water soluble sodium aluminate. Okay, what it will form? It will form the soluble sodium aluminate. This means that bauxite is leached by sodium hydroxide solution. Okay, so you can see here Al2O3.2H2O. How many water? NH2O was written now. We are taking 2H2O plus 2 NaOH. Okay, will give you 2 NaAlO2. Okay, plus 3 H2O. Okay, you are going to learn by heart the reaction. Okay, students, write and practice it. Yes. Now, the iron oxide in the gangue does not dissolve in aqueous sodium hydroxide. Now you know iron oxide is also there. It is separated by filtration. So we have to do another process, that is filtration. However, silica in the gangue dissolves in aqueous sodium hydroxide to form water soluble sodium silicate. Aqueous sodium aluminate is diluted by putting in water and is cooled to 50 degrees Celsius. This results in the precipitation of aluminium hydroxide. So NaLO2, okay, plus 2H2O, we are putting, what we are doing, putting in water and we are cooling it to 50 degrees Celsius. Then what you are getting, students, you are getting NaOH plus AlOH thrice, that is sodium, you are getting sodium hydroxide and aluminium hydroxide. Okay, you are getting, is it clear students? Okay, now, so we will proceed students. In the Hall's process, the ore is powdered and then leached by heating with the aqueous sodium carbonate in the digester to form water soluble sodium aluminate. Again sodium aluminate is formed, but students here we are using sodium carbonate. Okay, not caustic soda. Then the insoluble impurities are filtered out. The filter, whatever the filter is there, filtrate is warmed and neutralized by passing carbon dioxide gas through it. This results in the precipitation of aluminium hydroxide. So again aluminium hydroxide is formed. So see here Al2O3.2H2O plus Na2CO3, okay, sodium carbonate gives you 2 NaAlO2 plus CO2 plus 2H2. Okay, then I am taking 2 NaLO2 plus 3H2O, I am passing water, plus carbon dioxide gas when I am passing it, neutralizing means I am passing water, gives me sodium. You will see that I am getting back the sodium carbonate and Na2CO3 plus what I am getting 2LOH thrice, that is aluminium hydroxide. Okay, the precipitate of LOH thrice obtained in both Bayer's and Hall's process is washed, dried and then calcined by heating at 1000 degrees Celsius to obtain alumina. Is it clear students? So 2LOH thrice gives you Al2O3 plus 3H2O. Okay, calcinized means what? Water is removed from it. Okay, and you are getting the alumina. It is heated to 1000 degrees Celsius. Okay, now second we are going to part is the electrolytic reduction of alumina. Okay, now in this method, electrolysis of molten mixture of alumina, melting point will be more than 2000 degrees Celsius, is done in a steel tank. You have a steel tank. The tank has a graphite lining on the inner side. Okay, the lining does not does the work of the cathode. So the lining which is there, it will be you can see here in the picture, the diagram which I am showing you. See here, you can see cathode graphite lining. Okay, a set of graphite rods deep in the molten electrolyte works as the anode. See here, this yellow color. Okay, these are those. Now cryolite Na3Alf6 and fluorspar CaF2 are added in the mixture to lower its melting point up to 1000 degrees Celsius. So here, see here, it is written mixture of alumina, cryolite and fluorspar. Okay, so these are fluorspar are added to the alumina. Okay students, I hope till here it is clear. Steel tank is there, molten aluminium, you are going to get it, and see outlet is here. Okay, we'll just read in the diagram what it is given. Aluminium is deposited on the cathode on passing electric current. Okay, you will get the aluminium getting deposited at the cathode. Okay, molten aluminium being heavier than the electrolyte get collected at the bottom of the tank. Aluminium is heavier, so see, you can see orange color it is shown. It is taken out from there. From time to time, oxygen gas is liberated at the anode, and at the anode you will get the liberation of the oxygen gas. Okay students, I hope till here it is clear. Okay, so the electrode reactions are as follows. Anode reaction, 2O2 minus, okay, gives O2 plus 4 electrons, oxidation. Cathode reaction, Al3 plus 3 electrons, and it will form Al. Okay, in liquid, that will be your reduction. Okay, the liberated oxygen reacts with the anodes to form carbon dioxide gas. So liberated oxygen, it will react with the anodes to form carbon dioxide gas. The anodes have to be changed from time to time as they get oxidized during the electrolysis of alumina. As you see, they are forming gases when oxygen is liberated. So the anode we have to change from time to time because they are getting oxidized. Okay, I hope it is clear. Anode reaction, cathode reaction, you have to learn by heart. Okay, so we have come to the end of today's presentation. Today we studied about the extraction of metals. In that you saw about extraction of aluminium. Two process you saw, Bayer's process and Hall's process to get the alumina, and then electrolytic reduction is done. I hope today's PPT you have understood. Whatever presentation for today what we have done you have understood. Please go through it properly. Okay students, we'll meet in the next presentation. Take care. Sai Ram.